Some quadratic functions provide us with the opportunity to use a very nice technique that allows us to see some of the properties of the quadratic function. And those are quadratics that can be factored. So, for instance, if we're looking at a quadratic in general form like y equals 6x squared minus x minus 35, and we can factor it, then we can tell something special about it. Now, to factor this trinomial, you could use the quadratic formula to come up with the roots, or quad on your calculator, or if you're doing it without a calculator, you'd be looking for two numbers with a product of negative 210 and a sum of negative 1. When the sum is really small, really close to 0 like that, you know the two numbers are going to be pretty close to the square root of 210 in this case, which is close to 15, 14, 15. In fact, 14 and 15 are the numbers. So the way we use those two numbers is to break apart that middle term, 6x squared minus 15x plus 14x minus 35, and then we look for factoring by decomposition. So we take out a factor of 3x, leaving us with 2x minus 5, and 7, leaving us with 2x minus 5. There's your common binomial, and the 3x plus 7 is left. Now, how does this help us? Well, if you set the y-coordinate equal to 0, you solve for the x-intercepts, or the zeros. So set y equals 0 to find, to find x-intercepts, which are sometimes called zeros. So if we let y equal to 0, and we've already got it in factored form, then it's very easy to find the zeros. Either that first factor, 2x minus 5, is 0, or the second factor, 3x plus 7, is 0. In the first case, that would mean that x was equal to 5 over 2, 2.5. In the second case, that would mean x was equal to negative 7 over 3, negative 2 1/3. Now, that allows us to come up with a sketch of the quadratic. We know it's facing up because it has a positive leading coefficient, and we now know that it passes through the x-axis in two places, at negative 7 over 3 and at 5 over 2. And if we wanted, we could go a little further, and we could say, well, we even know where the vertex is, because the vertex, because of the symmetry of quadratic functions, it's going to fall exactly halfway in between the two zeros. So in other words, exactly halfway between negative 7 over 3 and 5 over 2. If you want to find halfway between those two numbers, you just take half of the sum of those two numbers. So 5 over 2 plus negative 7 over 3 is minus 7 over 3. And this becomes a half of 15 minus 14, which is 1/6. And so you end up with 1/12. Now, finding the y-coordinate is a little bit more tedious, because you have to take that x-coordinate and plug it into the original quadratic, 6x squared minus x minus 35. And that's going to be a little ugly without a calculator to help you. Turns out to be minus 841 over 24, which is really close to negative 35, which isn't too surprising because we know the y-intercept is negative 35, and obviously this vertex is very close to the y-axis. Alright, so let's see how we can use this going in the opposite direction. If we are given a sketch or a graph of a quadratic that passes through the x-axis, so for instance, let's say it passes through at negative 5 and at 2, so it's got zeros of negative 5 and 2, and let's say we know one additional point, let's say it passes through 1 comma 4, then we can find the exact equation of this quadratic function. So the 0 of negative 5 corresponds to a factor of x minus negative 5, which we would write as x plus 5. The 0 of 2 corresponds to a factor of x minus 2. Now that quadratic left as it is passes through the same two zeros, but obviously if that's the only thing we're graphing, it would be facing up, and this one is facing down. So we're not taking into account that leading coefficient, so we've got to put the leading coefficient in, A, and then to find A, we just need one point that's not on the x-axis, one point that's not one of the zeros, and that point in this example is 1, 4. So we let y equal to 4 and x equal to 1, 1 plus 5 and 1 minus 2. And so we end up with 4 equals a times 6 minus negative 1, or negative 6. And so we divide both sides by negative 6, and 4 over negative 6 reduce that to negative 2 over 3. And so now you've got y equals negative 2 over 3, x plus 5, x minus 2. And that's the equation of this quadratic function. And once again, if we wanted to find the vertex here and we know the zeros, it's very easy. It's just halfway in between negative 5 and 2. To find halfway, add the two numbers. Negative 5 plus 2 is negative 3. Divide that by 2, you get negative 1.5, or negative 3 over 2. And then if you wanted to find the y-coordinate, now you've got the full equation of the quadratic. Just plug it into that equation. Let's take a look at another example along the same lines, but this time with zeros that are not integers. This can be a little bit trickier. So here's our parabola. It's facing up. As soon as we see it facing up, we know the a value, that leading coefficient, is positive. And let's say it has zeros of negative 3/4 and a half. And we'll give it another point so we can find the full equation here of 0, negative 6. Okay, so this 0 of negative 3/4, we could write the factor corresponding to that 0 as x minus negative 3/4. So x minus a negative becomes x plus. And that would be fine. Similarly, we could write the factor corresponding to a half as x minus a half. But normally when we write factors, we want to have integers, and so it is possible to turn these factors into factors that have integer coordinates. If you think about how you ended up getting the zeros, you set the factors equal to 0. So if you have x plus 3/4 equal to 0, a solution to that equation is obviously negative 3/4. But if we multiply both sides of this equation by 4, we end up with another equation that also has the same solution, negative 3/4. So we could use that as our factor for x plus 3 instead of x plus 3/4. And same thing with x minus a half. If you think of the equation x minus a half equal to 0, multiply both sides by 2, you get 2x minus 1 equals 0. So 2x minus 1 would be a perfectly acceptable factor as well, because it would yield the same root of a half. And it's a little easier usually to work with these factors that have integer coordinates. So we could then say, all right, this quadratic function is y equals a times 4x plus 3 and 2x minus 1, and then plug in the point 0, negative 6. 4 times 0 is 0, so you get 3, and 2 times 0 is 0, and you get minus 1 there, and then divide both sides by negative 3 to get positive 2. So the equation of this parabola is 2 times 4x plus 3 and 2x minus 1. Now, you can try this for yourself. If you used the original factors, x plus 3/4 and x minus a half, you would get a different value of a, one that is actually much larger. I think it would be 8 times larger, so it would be 16. And then it's going to look quite different when you write the quadratic function in factored form. However, if you took both versions and expanded them so they were in general form, they should be identical because you're dealing with the same quadratic function. So in a way, there's really only one way to write it in general form, but sort of a variety of ways to write it in factored form depending on whether you want your factors to have just integer coordinates or not. Alright, let's take a look at a little word problem. Let's say that there is a parabolic arch. And the arch spans 10 meters. So the arch spans 10 meters. And 2 meters from the end, or from one end, the height is 3 meters. So how high is it at the center? So the key to this is superimposing a coordinate plane on the arch and thinking of the two ends, one end being at the origin, so 0, 0, and the other end being at 10, 0. That's your span of 10. And then 2 meters from one end, we could say the point 2, 3. So 2 meters from the end has a height of 3. And then we were just trying to figure out where is the vertex. Well, again, if you know the zeros, you know the x-coordinate of the vertex. It's just halfway in between 0 and 10. So we already know the x-coordinate is 5. But we're looking for the y-coordinate, which is the height. So a factor of 0 leads to a root of 0 leads to a factor of x minus 0. In other words, just x. And a factor of 10, or a root of 10, leads to a factor of x minus 10. So the equation of this parabola is y equals a x minus 10. And we can plug in the one point that's not on the x-axis, 2, 3, to figure out the magnitude of a. So 2 minus 10. 2 minus 10 is negative 8. So we get negative 16. A is equal to 3. So a is equal to negative 3/16. So this quadratic we could write as y equals negative 3/16 x minus 10. And now, to find the height of the arch at the center, we just plug in an x value of 5. So we get y equals negative 3/16 times 5, and 5 minus 10, which is negative 5. So the negative times a negative becomes a positive, which is a good thing, because we're expecting a positive y value. And it's 25 times 3, so 75/16, which is a little bit bigger than 4.5. So 4.5 meters is the height of the arch, or a little bit bigger than 4.5 meters is the height of the arch at the center of it.